Hi, so this session is a basic session on solving equations, and we'll be focusing on linear equations. Now, of course, we know that an equation is a mathematical statement that contains an equal sign. So just to recap on a few basic things, an equation has to have an equal sign, and when we solve an equation, we are trying to find an unknown number, and it's represented by a variable. And we know variables are symbols that represent numbers, and we usually use letters of the alphabet. In this case, in this example, you can see X is being used, and we have to figure out what X is. And when we do this, we are solving the equation. So when the question asks you to solve, you are finding an unknown variable, what number it stands for. Sometimes you can have more than one unknown variable, but at this stage we'll be looking at just one. Now if you look at this example just here quickly, in your mind you can actually work this out mentally, because this is saying, if we were to put this in a worded problem, is there a number plus 4 that gives you 7? Now we know that, well, the only number plus 4 to give us 7, the number has to be 3. So we can solve mentally that X will equal 3. Now, of course, we have to do this also mathematically, because sometimes equations can be quite complex and we need to take it step by step. So let's start with a few examples. So let's start with these 4 basic examples, and then we'll eventually get to harder equations. Now, with the first one, we see that it's asking us, is there a number plus 4 to give us 10? And mentally we know 6 plus 4 will give us 10. So straight away we can mentally work this one out. X will have to equal 6, because 6 plus 4 is 10. Down here we've got a number minus 2 to give us 6. Well, we know that 8 minus 2 will give us 6, so mentally we can work this out. X will have to equal 8. Down here, we know in between a 5 and an X there's an invisible times there. So we are saying 5 times a number that equals 45. Well, I know that 5 times 9 is 45, so for this one, X will have to equal 9. And down here, a number divided by 2 to give us 4. Well, we know that 8 divided by 2 is 4, so X will have to equal 8. So I have just solved these equations quickly and without showing any working out, because these are quite basic and we can do it mentally. But of course, in maths, we always have to show structured working out to show the teacher that you know what you're doing, in case you make a mistake with your final answer. So now, to solve these mathematically, we know we do the inverse, or the opposite of what operation we see. So if we have a look at X plus 4, that equals 10, we can see that we want X. So to solve an equation, you can see X has to be on its own, and X equals a number. We cannot have anything else other than the X visible on this side here. Otherwise, we haven't finished solving. So you can see X plus 4, X is not by itself. So we only have one step for this, because there is only one number on this side, and that is 4. Now the opposite of plus 4 is to take away 4. And what we do to one side, we must do to the other side. Just like with fractions, what you do to the top, you must do to the bottom. So otherwise, your equation won't be the same. It won't be balanced. Now that cancels out to be 0. So X is equal to 10 minus 4 is 6. And we got our 6, showing some working out. Down here, X wants to be by itself, so there's one step we have to do. This 2 we have to get rid of. Now we can see this 2 is a negative 2, and the opposite of minus 2 is 2 plus 2 to give us 0. And of course, we must plus 2 on this side. And so X will equal 6 plus 2 is 8. Down here, we have 5 times a number to give us 45. We know it's 9, but because there's times, in this case, the 5 here is joined to the X by multiplication. Up here, it was sort of joined to the X by subtraction and addition. So the opposite of multiplication is to divide by 5. And what you do to one side, you must do to the other. The 5's cancel off, so X, I'll squeeze it in here, X will equal 45 divided by 5 is 9. And we know that when we show division when solving equations, we don't write division like this, divided by 5. Get into the habit of using the vinculum, so the fraction line divided by 5, because it'll make it more easier later on when questions get harder. Now last one for this section, we have a number divided by 2 to give us 4. Yes, we know it's 8. But this 2, how is it joined to the x? It's joined by division, because we are saying x divided by 2. And the opposite of dividing by 2 is to times by 2. And you notice this 2 is on top, because that 2 is really over a 1. And if it's on top and a 2 on the bottom, they cancel out. And of course, we must do the same to this side. So we end up with 4 times 2. So x will equal 8. Okay, so we've used all the operations and shown their inverse. So the opposite or inverse of addition is to subtract. The inverse of subtraction is addition. Inverse of multiplication is to divide. And the inverse of division is to multiply. Now with our next 2 examples, we are combining a few of the operations, and to solve these equations, it involves more than one step. And with question 5, well, if we can try and do it mentally, 2 times a number plus 5 to give you 15. What is the number? And you can see that to solve this, there are 2 steps, because there are 2 numbers that are with the x and we have to get rid of. And that is a 2 and the 5. Now, the one that goes first is the plus 5. And a way that you can remember is this plus 5 here, at this stage, it's the sort of the furthest number away from the x. And that 2 is sort of closer. So we'll get rid of the 5 first. And another reason why we get rid of this 5 first is because if we divide by 2 first, okay, which you technically can do, you must also divide this plus 5 by 2 and also divide this 15 by 2. And you can see how we end up getting fractions, and it actually gets more complicated and we're making it harder than what we need to. So remember, the plus 5 will go first. So opposite of plus 5 is to take away 5. And we do that on both sides. And 5 take away 5 is 0. And we're left with 2x is equal to 15 take away 5 is 10. And our final step now is to get rid of these 2. So we have 2 times x. So divide by 2, that cancels out. So x will equal, and 10 divided by 2 is 5. And we can check, because we didn't do it mentally first, we can also substitute this into the equation to see if we are correct. And we should, if we put x is equal to 5 in the question, we should get 15 as our answer. So let's try it. If we had 2 times x, or 2 times 5, which is 10, and 10 plus 5 is 15, we end up with 15 on both sides, or 15 equals 15, and so it's true, and we have the correct answer. So let's try the one down, let's try 6. So we have 2 times a number divided by 4 to give us 5. So just so we can't work that out mentally, I'll just rub this off so it's not so squished up. Now, the x needs to be on its own, and we can see there are 2 numbers sort of annoying the x. Now, which number out of the 2 and 4 looks like it's the furthest away? Well, you can see it's the 4 on the bottom that looks the furthest away. Both the 2 and the x are on top. So we must get rid of this 4 first, and the opposite of dividing by 4 is to times by 4, and we must times this side by 4. So your next step is to cross out the 4 and cancel out. So it's gone, and we end up with 2x is equal to, and 5 times 4 is 20. And now our final step is, well, opposite of 2 times x is to divide by 2, that cancels out. So x will equal 20 divided by 2 is 10. And let's just check and see if we did the correct thing. If we substitute x is equal to 10 into our original equation, so instead of 2 times x, if x is 10, 2 times 10 will give me 20, and 20 divided by 4 gives me 5. So we end up with 5 equals 5, so our answer is correct. Our equation holds true. Now with our next equation, it's starting to look a little bit more complicated, but it's just as easy. And you can see the x is not on its own, and there are 1, 2, 3 numbers that have to be removed. And so to solve this equation, there are just 3 steps. Now, you can actually number what goes first, if that helps. So out of the 2 and the 5 and the 3, which one looks like it's the furthest away? And you'll notice that you might think it's a plus 5, but it's not, because the 5 is actually above the vinculum here. And on our next example, I'll show you what I mean by not being above. So this 5 isn't actually a 5. It's actually 5 over 3. So just keep that in mind. It's like, just quickly, if we look at some fraction skills, if we had, for example, 2 plus 3 over 3, just say, okay, we can separate this and say, well, we've got 2 over 3 plus 3 over 3. And if we add them, we'll end up having, either way, we'll end up having 5 over 3. And we can add this step when solving fractions, but usually we don't write this step. We just automatically go 2 plus 3 is 5, and the denominator stays the same. So that's the same sort of thing that's happening with our equation above here. I'll just write this out. So because this 5 is also above the vinculum, above this line, it doesn't go first. This 3 is the one that goes first. So the opposite of dividing by 3, because you can see how this 3 here is sort of attached to the x by division. We have to times by 3 and times by 3. So the 3 cancels out, and we end up with 2x plus 5. This vinculum, the line can go and the 3 is gone, and 5 times 3 on this side is 15. Our next step is, well, the opposite of plus 5 is to take away 5 on this side and take away 5 on that side. And we can see how the plus 5 is the furthest away from the x, so the 2 will be last. And sorry, I forgot to mention, if you wanted to number these, so far the 3 was the first to go, second to go was the 5, and therefore the third one to go is the 2. So if it helps, you can number them. And now we end up with 2x is equal to 15 take away 5 is 10. And our final step, well, we've got 2 times x, opposite of times is 2 divided by 2, that cancels out, and 10 divided by 2, so x will equal 10 divided by 2 is 5. Okay, and you can substitute this back into the original question, the original equation, to see if this side will give us 5 when x is 5. And we'll do it quickly now. If x is 5, 2 times 5 is 10, 10 plus 5 is 15, 15 divided by 3 gives me 5. So I am correct, or we are correct. Now with our next equation, once again, x is on this side, and there are 3 numbers, 1, 2, 3, that will have to be removed. So this involves 3 steps. Now with the previous question, if you remember, the denominator, we had, for example, 2x, see the 2x plus 1? The plus 1 on the other example was on top. Now, in this case, you can see this number here, which is 1, is not on top of the vinculum. It's on its own. So therefore, plus 1, this is just a positive 1. It's not on top of anything, so it's just 1. So in this case, this one will go first, and then the 6, and then the 2. Okay? So first step, second step, third step, and that's it. We'll be finished. So opposite of plus 1 is to take away 1. So take away 1 on both sides. That cancels out. And we have 2x over 6 equals 5 take away 1 is 4. Now our next step, step 2, is to get rid of the 6. So instead of dividing by 6, we need to times by 6 and times by 6. So that cancels out. So we end up having 2x is equal to 4 times 6 is 24. And our third step is to get rid of the 2. So finally, we've got 2 times x. The opposite of 2 times is to divide by 2 and divide by 2. This cancels out. And 24 divided by 2, x will equal 12. And we have solved the equation. So just keep in mind, this plus 1 was on its own, not on top of the vinculum, so it went first. Now with the next few questions, they look quite simple, but there's something here that confuses a lot of students, and that is the negative. So if you look at question 9, we have negative x is equal to 2. Now this negative can't be there because the x is still not on its own. And we know that the invisible number next to the x is a 1. And to show this mathematically, we are saying negative 1 times x, and the opposite of times is to divide by the negative 1. And of course, divide the 2 by the negative 1. The negative 1 and negative 1 will cancel here, and we end up with x will be equal to 2 divided by negative 1 is negative 2. Now, we'll come back to this in a second. Let's try this one down here. You notice there are 2 negatives on this side, but we'll do the exact same thing. So divide by a negative, or negative 1, that's invisible. That cancels out. Divide by a negative 1, and this time we end up with negative 2 divided by negative 1 is a positive 2. So that's what's actually happening. And a shortcut to do this, so if you ever have almost finished solving an equation and you end up with a negative on this side, all you have to do is basically get the negative and put it on that side. So for this one, if I grab the negative and put it on this side, I ended up with negative 2. If I grab the negative on this side and put it there, the 2 negatives made a positive. Or another way for 10, if you have, I'll do another example. If you have 2 negatives on both sides, so negative x equals negative 3, another way is you can actually just cancel off the negatives. So cross off one negative on this side, cross off one negative on that side, and we're left with the positive 3. Okay, so keep that in mind. But of course, if you do have a negative left over, you have to either divide it by a negative 1 and bring it to the other side, or just do it the short way, which is just cancelling off the negatives, or just bring it to that side anyway. So with our next example, you'll notice that we've got 5 take away a number to give us 1. What is 5 take away something to give you 1? Well, we know x will have to equal 4. And it's a positive 4. So we have solved this mentally. Now, let's show some working out mathematically. And these types of questions actually confuse students, and they usually get it wrong. So, and the reason is they see a negative here, a takeaway, and they think, oh, 5 take away x, so we have to plus x on this, plus 5 on this side, and plus 5 on that side. And that is a big mistake, because that 5, it is not negative, it is positive. Remember, we always look to the left of a number. On the left of 5, there is nothing there, or an invisible positive. If that's a positive 5, the opposite of positive 5 is to minus 5. And what we do to one side, we must do to the other side, and minus 5 there. And that will be cancelled out to be 0. And we're left with, this negative is still there. We are left with minus x equals, and 1 take away 5 is actually negative 4. And you can see what's happened with the negatives. We've ended up with a negative on this side and 1 on this side. And we know we want x to equal a positive 4, because we can solve this one mentally. To get a positive 4, all we have to do is cross off these negatives, or like before, you can bring this negative to that side, or just divide by negative 1. But the fastest way is just cross off 1 on this side, 1 on that side, so x will equal positive 4. And we got our correct answer. So just remember, this negative belongs to the x here, and that 5 was positive. With our next example, we have minus 2 times a number to give us positive 10. Well, I know that 2 times 5 is 10, and to get a positive 10, I'd have to go minus 2 times minus 5 to give us positive 10. So mentally, I know that x will have to equal negative 5. So that should be my answer when I solve the equation. Now, if you notice this 2, it is a negative 2. Now, at first you might think we have to go plus 2 on this side and plus 2 on that side, but we actually don't do that. Even though it is a negative 2, how is that 2 next to the x? Is there a plus or takeaway separating the 2 and x, or is there an invisible times? We know that 2x is, or in this case negative 2x is saying minus 2 times x. So that minus 2 is joined to the x by times. So this is not subtraction, this is just saying a minus 2. So what you do is divide by the exact same number, divide by minus 2, and divide by minus 2. And minus 2 divided by minus 2 cancels out. And we end up with x equals 10 divided by minus 2 is minus 5. And we got our answer. So just remember with this one, the negative 2 was joined to the x by times. Now for our next example, you notice that we are now solving, I'll change I had f instead of x, but I'll put x just so we are consistent with this session. So we can really use any letter we want, or any variable. Now, you notice that the x is on the right-hand side of our equation. Now, if you are comfortable solving this the way it is, that's fine. But I'm going to show you a way you can actually switch this without changing anything. And that is to just rewrite what you see, but write them on opposite sides. So on this side, what do I have? I have x minus 15 divided by 3. So I'm going to write x minus 15 divided by 3. So now it's on this side. What comes next? Equals. So equals. And then we have a minus 4 and minus 4. And you can see how the x is now on this side. And it's easier to solve if you prefer with x being on this side. And now to solve this, what goes first? The 15, the takeaway 15, or the 3? Well, because that 15 is above this line here, okay, the 3 goes away first. And we're dividing by 3, so the opposite of dividing by 3 is 2 times by 3. And times by 3. And we're left with x minus 15 equals minus 4 times 3 is minus 12. And now with the minus 15, we plus 15 and plus 15, because the opposite of take away 15 is the plus 15. And we can see how this 15 is joined to the x by subtraction. Okay, it's not saying x times 15, it's saying x take away 15. And that becomes 0, and minus 12 plus 15 on that side. So we have x equals, so minus 12 plus 15, the difference between them is 3, and it will be a positive 3. And that's our final answer. So now let's just check and see if x equals 3 is the correct solution. So in our equation, we'll use this one up here. If x was 3, so I'll rub out my x. And if I put 3 there, let's have a look and see if we get negative 4. 3 minus 15. So 3 minus 15, that is negative 12. And negative 12 divided by 3, you can use a calculator, is negative 12 divided by 3 is actually negative 4. And I would have negative 4 on this side equals negative 4 on that side. So the equation is true. So we have the correct solution. So our last example for this session is this one here. And instead of x, I've used a y now. Now have a look and see what you have. Here's the y, and we want y to be by itself to solve it. So we can see there'll be 1, 2, 3 steps involved. Now let's establish which one is to go first. Now you notice this 4, okay, this plus 4, it's sort of on the opposite side. We're used to having something like this. For example, 7y over 8 plus 4. That's what we're sort of used to. And actually this is the same thing as what we have on the bottom. But I'll leave it the way it is, just in case we may make a mistake by making too many changes. So this 4 is positive, and it's going to be the first one to go because this 4 is not above this vinculum here. It's on its own, so that goes away first. Then it'll be the 8 to be the second step, and then the minus 7 will be our third step. And the minus 7, you can see how it's right next to the y and joined by multiplication. So this 4 is positive, and always look to the left. It's a positive 4, and the opposite of positive 4 is 2, minus 4. So I'll use the red. So minus 4 on this side, that cancels off because it's 0, and we have minus 4 here. And minus 3 minus 4 will give us minus 7. So we end up having minus 7y over 8, that's what's left, equals minus 7. Our second step is to get rid of the 8. So instead of dividing by 8, we have to times by 8. And that cancels off. And we must times 8 on this side. So we end up having minus 7y equals minus 7 times 8 is minus 56. And our final step, finally, we know we are not saying 7 take away y, we are saying minus 7 times y. And the opposite of times is to divide by the minus 7. That cancels out, divide by minus 7. And finally, y will equal, well, 2 negatives make a positive. 56 divided by 7 is 8. And there's our final answer. So keep practicing solving equations, but we have pretty much covered a lot of the basic skills that you need to solve basically any equation.